All right, this is a video on increasing, decreasing constants, and then relative maximums and relative minimums for functions. So just to quickly define them, when a function is increasing, we're going to look from left to right, and it's going to be going up as we move left to right. Pretty intuitive there. Decreasing. We are going to be going down as we go from left to right. If it's constant, it's flat as we move left to right. Everything is based on, with these four ideas, is that's not a very straight line. Sorry about that, folks. Is all based on all based on going from left to right. So as we look at the graph from left to right, you can almost think of it as a roller coaster ride. If you're going up, and then you go down, it's all going from left to right. Okay. Relative maximums and relative minimums tie right into them. So if it's a relative maximum value, then it's when you change from increasing to decreasing. So it's the point, and it's always a point. It's a point where we're changing. There's a change from increase to decrease, which that means a relative minimum is a point where you get a change from decrease to increase. I've had a few people describe these. This maximum is like a hill. It's like the top of a hill. Again, that top of that hill. Whereas a relative minimum is going to be the bottom of the valley, like that very lowest point on the bottom. Okay, and that can be a sharp valley or it can be like a rounded. It just has to change direction is what we're looking at. So what we want to do is take these and just be able to find those and write these. We always write these in interval notations with this over here. So we're going to use our x values to communicate this. So we're going to use x values in interval notation for that. For our relative max and minimums, we're going to go like x equals, wherever it is on the x. Or if you want to do an ordered pair, you can. I'm going to kind of focus on x equals, but because it is a point, you can do an xy point. Okay, so let's start with this graph on the left. This graph on the left, if you go from left to right, it decreases until I get to this point, and then it increases. There is no constant. So this increases from this point on. And I always go, I'm working left to right. So this point here is at -6. So to write that, I would say -6, comma, and as I go to the right, it's increasing until I get to positive infinity. And I'm just going to go with parentheses around that. This is an interval notation right here, okay? For decreasing, it's decreasing from all the way here to the left. So think about it, all the way to the left until I get to that point right there. So that would be from -infinity to -6. And for constant, there is not any, so it's not really applicable for this graph. A relative, if I look at relative maximums, I have no relative maximum because it never changes from increasing to decreasing. So this again would be not applicable as well, but there is a relative minimum. Okay, my relative min is when it changes from decreasing to increasing. And so that's going to be this spot right here at x equals -6. That's where my relative minimum is. So that's how you walk through these. You're looking for increasing, decreasing, constant, relative max, relative min. Again, increasing is when it's going up from left to right. And we always communicate with the x-axis. So just ignore this. Essentially we can just ignore this y-axis. We're only looking at the x-axis here. Okay, let's do that with this one. So this one I've got decrease until I get to this point, and then increase the rest of the way. So again, my increase is going to be at this point, which that looks like at -4. So that'd be -4 to infinity. And I'm going to do interval notation just like that. And my decreasing is all the way from here, all the way till I get to to this point right here, so that'd be negative infinity to negative 4 as well. There is no constant, so that's going to be not applicable. And then my relative max, I have none, but I have a relative min at x equals negative 4 would be where my relative min is. And relative max is not there. So that's not applicable as well. Okay? So that's what that example right there. All right, looking at this next example here, again, I'm looking for where it increases, decreases, constant, relative max, relative min. If I look at this function, I work left to right. It is always going up. Even right here, it never goes flat. It's always increasing the whole time. So my increasing is going to be from negative infinity to infinity. My decreasing is not applicable because there is none. And same thing with my constant. My constant's going to be not applicable as well. The other thing is there's no turn, so my relative max and my relative min are also going to be not applicable as well. So that's just how that works, just like that, okay? Looking at our next one here. So looking at these next couple, this gives us a little bit more variation here. So again, as I work left to right, I am increasing till I get to here, and then I'm decreasing till I get to this point, and then I'm increasing. So this value at negative 1 and at 5 are really important. So for my increasing, there are two sections. So now if I have two sections, I got to do them separate. So negative infinity all the way till I get to negative 1. And then the other one is from 5 to infinity. And again, that's because I work left to right. It's not because this is facing up. It's that it's going up from left to right. So from here to here, and then from here to here is increasing. Okay? My decreasing is going to be this part right here, which on my x-axis is from this value to this value. So this decreasing is going to be from negative 1 to 5, and that's the only section that is decreasing right there. I have no constant, so my constant's not applicable. I do have a relative max, so my max value is going to be this point that's right here when it changes from increasing and decreasing, which we're just going to say x equals negative 1, because that's where that point is if you look at that. And then my minimum value is where it changes from decreasing to increasing. It's the valley here, so that's going to be at x equals 5 is where that minimum is going to be. Okay, let's just look at a couple others here. So increasing, decreasing, let's go constant. Okay, so increasing, if I look for my increasing sections, anything that's going up from left to right, that would be this section right here, which is from here to here. So this part right here is increasing. That's from 1 to 2. That's the only part that's increasing. My decreasing sections are this part from here to here, which that would be from this point to this point. And then it's also decreasing from there down, which would be from here to there. So there's two sections for that. That would be 1, 2, 3, 4. That would be negative 4 to 0. And then it also from 2 to infinity. So from here to here. There is some constants in this. There's a piece of constant right here. And then right down here, that would be from this point to this point. And then from this point to this point. So that's going to be from negative 5 to negative 4. And then also from 0 to 1 would also be where I'd find that. Relative maximum, remember my definition, my relative maximum has to change from increasing to decreasing. There is one spot where it changes from increasing to decreasing. That is this point right here. And that is at 2, so we're just going to say at x equals 2. Guys, this point right here, this spot is not an increasing because it's from constant to decreasing. It has to go from increased to decreased, not the other way. And then my minimums, I know you guys are going to look at this and be like, hey, there's a minimum down here, but this goes from decreasing to constant, and then constant to increase. Remember, my definition is it changes from decreasing to increasing at one point. So this is not applicable as well because there is not that decrease to increase. It's decrease to constant. Okay? All right, this has been your Math Moment with Mummy. Adios.